Let's see, it is 1:05. Are we all good to go?
I'm going to do some introductions, if you don't mind.
Fantastic. Yeah, go for it.
All right. Good afternoon and welcome to session 4 in the science strand. This should be basics. Yeah, basic strand of the high school climate change symposium, weather, climate, and extreme events. This session is going to be recorded. Our speaker for the session is meteorologist Katie Nickolaou from KMEG. Katie Nickolaou is the weekday morning meteorologist for Siouxland News. Is that how you say it?
Siouxland News.
Siouxland, okay. At Sunrise in Sioux City, Iowa. She was born and raised in Battle Creek, Michigan, where she experienced everything from extreme lake effect snow events to tornadoes. She graduated from Valparaiso University in 2019. Did I say that right?
You got it right.
Nice. With a degree in meteorology and a minor in digital media. An avid storm chaser, Katie often takes her camera out into the field to report live on tornadoes as they occur across her viewing area. Thank you so much, Katie, for coming and sharing.
Oh, thank you guys for having me. This is literally the most exciting thing I have going on, and I love it.
All right, well, you're all set to go whenever you want.
Fantastic. All right, everyone. So I have my presentation here, and we'll just click on over to it as it loads very slowly. There we go. All right, so we're going to be talking about weather, climate, and extreme events and how they all work together and how it's all interconnected. Now, I want to point out this picture here. This is actually, most of the storm pictures that you'll see in this presentation are ones that I've taken while out storm chasing. That little drop down on the cloud there is actually a wall cloud that turned into a tornado. And tornadoes are actually very good indicators of how the climate is changing, which we'll get to in just a moment. Now, first off, the basic thing is we need to know the difference between weather and climate. And it's something that can get a little tricky to understand. Basically, the best way to describe it is weather is in the short term, whereas climate is in the long term. The weather is day to day, how it changes from week to week, but climate is something that's set up over time. A 30+ year period is what we usually look for, 30 years of data or more. Now, a great example of this is the high temperature on February 15th, 2021 in Sioux City was 5 below zero. For the high temperature, wind chill, we won't even get into that. But the average temperature on February 15th is around 35 degrees. So we were well below our climatological normal. That's not going to really change the climatological history because that's 1 year out of a 30-year span. Now, this can still be a little confusing, so I use this as the best way to understand it because this is what made it click in my brain when I was in college and really cemented the difference between weather and climate. The weather tells you what you need to wear each day. You look in your closet, you grab what you need, either a jacket or shorts or flip-flops or sneakers. You look at climate, it tells you what to have in your closet. If you live, say, in Alaska, you're going to have more winter clothes because historically, it has been cold. You live in Florida, you might have one long sleeve windbreaker jacket, but mostly you're going to have shorts and t-shirts. And that's the difference. Weather day to day, climate tells you what you need for a very long period of time. And we have so many different types of climates out there. I mentioned the difference between Alaska and Florida. Well, look at this map. This is the Köppen-Geiger climate classification. And simply put, it breaks up 5 different types of climate and breaks them into subsections and then more subsections within that. So you get all those different colors that indicate different types of climates. And you see there from 1980 to 2016, well, that's a 36-year difference. That's a 36-year time span in which information was taken and updated. So they're really following that true climate classification by getting that select data and putting it all out. And you can see all those different kinds, and they actually interact in very unique ways. Now we know what the climates are, we know what it is. Let's talk about how it's changing, because there are differences between naturally occurring climate change and human-caused or advanced climate change. Ever since the Ice Age, we have seen warming, natural warming, but then you get that human-caused climate change and it causes it to grow incredibly faster than it normally would. So those are 2 different types of climate change. Most people just talk about climate change as a blanket statement, but there's actually many more different nuanced parts of it. Now, we also need to look at the history of it. I mentioned 30 years of data or more. That is the most stressed, underlined, italicized thing I can say in this entire presentation. Make sure that if you're talking about climate, it's not just 1 year, it's not just 5 years, because that could just be a global cycle that's going through. Some years you have a 5-year or 10-year stretch of warmer than average temperatures. Other times you have a 5 or 10-year stretch of below normal average temperatures. So you really have to look at the long term. Otherwise, you start to get some changes, some bias in your information, and that's what causes so much conflict when talking about climate change. And also, when we talk about global climate change, consider the entire globe and look for the signs of it. We have an entire Earth worth of data to look at to find how climate change is affecting us. And one of the best ways to look at that is to go back to the difference between weather and climate, because they aren't completely separate. Weather goes into climate, and reversed, climate can impact the weather and how it changes. For example, severe weather events. Now, when we talk about severe weather, that is just simply being put the type of weather that could cause harm to people, property, animals, anything that could do damage and cause harm or death. And there are some very common types of severe weather that we encounter. Thunderstorms, for example, can be severe thunderstorms if they have large amounts of hail in them or strong winds. Tornadoes are severe weather. Hurricanes, flooding, even drought, the lack of rain or storms, that is a type of severe weather. And of course, blizzards, because it's winter, have to throw that in. Now, these are weather events, severe weather events, but those climate conditions have a big effect on them because they can impact how often they happen, how intense they can be, the different tracks that they take, because of if the climates shift a little bit in their positioning, that changes the position of where those weather events can occur. One of the great things to do is look at severe weather events. This is a storm that happened pretty much from Colorado into Kansas. I believe we chased it everywhere we could. And this storm happened in a classic spot for storms, which is known as Tornado Alley. You see on this map, this is the average annual frequency of tornadoes in the United States. Pretty much matches up with what you've been told your entire life. The majority of storms happen over towards Kansas, Oklahoma, and Texas, and even up towards places like where I am in Sioux City, where we meet up in Nebraska, South Dakota, and Iowa. Those areas that have strong thunderstorms the most frequently and tornadoes the most frequency are known as Tornado Alley. Now, that, like I said, encompasses most of the central US, but you notice that those colors are a little bit shifted to the east now, including places like Illinois and Indiana, even down towards the southeastern United States. Well, that's actually something that we're keeping an eye on because of a changing climate. The reason we have Tornado Alley where we have it is because we get that cold air from the Rockies sinking in. We have that warm, moist air from the Gulf of Mexico running into that. We even get a little bit of dry air in from the southwestern United States, from the desert areas. And all those combine in this general central United States area to really kick up thunderstorms. With tornadoes, you need warm air down below, cold air up aloft. They converge as one tries to rise and one tries to sink. You get that spin, you get tornadoes. Now, we have to talk about that warm air and the cold air, but we also need to talk about 4 ingredients that you need for tornadoes: shear, lift, instability, and moisture. Shear is simply wind shear. You get wind coming up from the south with that warm air. You get cold air coming in from the northwest. That causes a difference in direction. That causes wind shear. Got that checked off the list. Can't really see too much of a change with that with climate change because you're still getting that warm air coming up from the south, cold air coming in from the north. But then you look at lift. Lift and instability are somewhat related because lift indicates that you have that warm air rising or something being pushed up. Well, you have more warm air, you're going to have more instability because warm air makes the atmosphere unstable when next to cold air. But it also increases that lift. And most importantly, we have moisture. You have climate change, you're going to be seeing an increase of moisture in the atmosphere. That will dramatically increase that category. So you all of a sudden, out of those 4 ingredients, have 2 or 3 that are now amplified by a warming climate. Then you also have something that other people might not have thought of back 50, 60 years ago, in that those changing ingredients will change the location of Tornado Alley. This is a look at how the frequency of tornadoes has changed, especially in the southeastern United States and the Midwest, as compared to the Central Plains or the Southern Plains as well. Now, that blue area, Texas, Oklahoma, and Kansas, that main triad that sees the most tornado activity, we still see the most tornadoes, but it's trending down. The number of tornadoes reported there is trending down just ever so slightly, as opposed to what you're seeing over towards, say, the southeastern United States, Mississippi, Alabama, Tennessee, Arkansas, that hot spot right there. They are seeing a dramatic upward trend in the number of tornadoes that are being reported. Well, that's starting to shift where Tornado Alley is. That's because actually of dry air. We talked about how moisture is amplified by global climate change, but we also have to talk about how dry air is going to be impacted. You see, when the climate changes, it makes wet places wetter and dry places drier. It just amplifies the extremes. And we get that dry air, like I mentioned, coming in behind the cold air from the Rockies out of the southwestern United States. Well, if that dry air gets drier, that means that it's going to extend or push farther to the east. That creates a very interesting dynamic. We have warm air and cold air. When they meet, you have a warm front or a cold front. When you have dry air or wet air, when they combine, you get a dry line. Dry lines are massive triggers for thunderstorms. You see here in this picture, this is actually from our GOES 8 satellite, and the dry line has been superimposed on top of it, where that dry air is behind it, the moist air is in front of it, and you see a line of those clouds, those gray bubbly clouds. Those are thunderstorms being pushed ahead of the line. Well, the farther that line pushes east, the farther the storms are going to push east, and the more likely those areas off towards the east will see tornadoes. Now, when that dry air gets underneath that moist air, that causes that lift. The dry air forces the moist air aloft. That's why you get the clouds, that's why you get the storms. When you have a little area like the southeastern United States, you have a lot of moisture down there. So you have increased dry air, increased moist air that just amplifies these storms and takes it to the nines. It just is incredible. And so when it causes the increased storms, it causes the increased tornadoes. And this is why it is so important when we're looking at it in terms of climate, because when the tornado alley shifts, it's going to impact more rural areas, places that have very small communities that might not have the infrastructure to support having tornado sirens or alert beacons or even cell phone towers, because most people do get tornado and weather information from their phones. And sometimes in the southeastern United States, you simply do not have that cell phone infrastructure to help with the signals and such, so you can't get that message out. You also have a massive increase in the number of prefabricated homes. We're talking mobile homes, trailers. Those buildings are easily destroyed by tornadoes or just strong winds. If a tree falls, it doesn't have the support beams that a regular house would have to prevent that tree from coming in and crushing everything below it. So those are two worries that we have with the southeastern tornado alley shift. But we also have that poor communication, like I talked with, and the surrounding natural areas. The land in the southeast is just unchaseable, as people in my field call it. If you chase a tornado into the southeastern United States, you will have dense forests, you will have muddy areas, you will have places that are prone to flooding, and of course, you have broken road systems when you get really far out into the rural areas. All of that makes it difficult for, one, storm spotters to actually get out and tell you where the storm exactly is, which impacts the communication of where the storm is and where it could be going. And also, emergency management response teams cannot get to these areas if the roads are blocked by a forest of downed trees. So all of those are concerns for when the storms shift farther to the southeast. Back in Oklahoma, Kansas, Texas, it's pretty wide open. It's generally pretty flat. You get to the southeast, you have so many more obstacles. So seeing that shift because of that increase in dry air due to climate change, all of it ties together and creates another hazard for people like me, meteorologists, to pay attention to, and people in the south who live there to also keep a close eye on. Now, for the southern United States, there's also another bad bit of news. We also have hurricane season. You see over on the top right there, that is GOES imagery. GOES is the satellite that we have for weather, showing of Hurricane Harvey that impacted Texas and caused so much devastating flooding. Well, When you think about it, hurricanes only form over the oceans. That's because of two things. It needs heat and moisture to survive. The warm ocean waters drive those storms. Well, more oceans are going to get warmer and we're going to have more water content out there in the atmosphere. That means that we could see an increase in hurricane intensity because you have that increase in ingredients that it needs, but also an increase in frequency. If you get any more storms to move over the oceans, even little ones, because of that dramatic increase in moisture and heat, some of those that wouldn't have necessarily developed before could develop now. And of course, not only just in the development phase can climate change impact hurricanes, but also when it makes landfall, when it impacts some landmass. You're going to see an increase in that water vapor content in the atmosphere, which of course in turn turns into flooding, massive flooding. That's one of the reasons why Harvey was such a devastating hurricane, because you see in that picture down on the lower right-hand side, that is what can happen to neighborhoods, to suburban areas, to urban areas, and of course, the rural areas. No matter where you are, if a hurricane's coming and you are near the center of it, you'll have damaging winds and intense rain. And that rain can extend farther out from the storm. So the larger a storm gets, the more intense it gets, the more intense that rain gets. And well, you see where I'm going with this. It's going to become much more difficult to protect people from these horrific floods, which don't just happen in hurricanes. You also have them with just plain old thunderstorms. That increase in water vapor means you'll have increased condensation when you get thunderstorms to form, and therefore you're going to have more rain. This is a picture from a storm chase that I had back in 2019. Easily one of the worst flooding events we've ever seen here in the United States. It cost farmers over $1 billion in crop loss and damages simply because of the rain. That doesn't even count how many homes were lost, the flooding in urban areas. This is just farm fields, which cover much of the area that saw these increases in rainfall. And not only did it damage crops and damage homes, but it also caused landslides in some spots, especially when you go into the western United States, into California. You'll be seeing more of those landslides and mudslides, and that can cause even more damage as well. So water, we need it to survive, but we get intense amounts of it. It's simply just hazardous. And we're seeing more water in the air, which will result in more water on the ground eventually as well. Now, I also want to point out one more thing about that picture. That was taken right before we went into a town that was just a normal town in the middle of, I believe it was Oklahoma, northeastern Oklahoma. The town had one road in and one road out because there was a moat of water surrounding it. Their power station, a large building, was completely submerged in floodwater. We aren't just talking about, oh, the roads covered in water. No, we're talking about entire towns just drowning in heavy rain from relentless back-to-back thunderstorms, which is something that we're starting to see a little more frequently as well. Then on the other hand, we also have extreme droughts. I mentioned before, you're going to see the extremes become more extreme. Wetter places will become wetter. Dry places will become drier. And those dry areas also are going to lose some of the biodiversity that they have. Some of the plants that need a little bit more water than others could start to die out. We could start to see more soil erosion. We could start to see more dust storms, which in turn causes poor air quality, which is very bad news for anyone who has problems with lungs, who have asthma, who have anything that could be impacted by that poor air quality that would occur naturally. We aren't just talking about smog in big cities. Nature itself can create poor air quality with that dust, something that I experienced on a chase as well. And when those dry areas struggle to have water, not only are you going to see the plant life suffer, but you're also going to find the populations that live there really start to have second thoughts about living there, especially say in places like California, where you're starting to see that water dry up. If that becomes even more of an issue, you could start to see other people leave and move to other parts of the country. So it's interesting to see how just the basic weather events that are driven by climate change could impact the entire country as a whole. Now let's talk about the costs, because an increased frequency in severe weather events means an increased cost to the areas affected by them. That is a statement that is drilled into us, not only by college and if meteorological courses for me, but from history as well. Look at 2019. I mentioned that 1 billion in flood damage to farms. Yeah, that was 20 billion for everything included. We're talking not only agriculture, but homes and businesses, large areas caused by flooding of the Missouri, the Arkansas, and Mississippi rivers. And then you also have just regular old tornadoes and hurricanes. All in all, 2019, the weather cost us $45 billion. That is a huge economic impact. And imagine if we had more hurricanes or more tornadoes or heavier rains, which cause more flooding. That number's just going to keep on going up. And we aren't just talking about money here, we're talking about lives. You have people who can't swim in floodwaters, which is most people, even great swimmers, struggle because of all the debris that's being kicked up, the mud, all of that. Simply put, when extreme weather becomes more extreme, you're going to have more deaths and more injuries from the weather. Take a look at 2019. 570 people died as a result of severe weather. Now, meteorologists, we try our best to give warning, to tell people you need to evacuate, you need to take these precautions, but it's just not enough, especially if communication is poor, like with the tornadoes in the southeastern United States. Look at this map from the National Weather Service. This is or a graph rather of the National Weather Service. 2019 weather fatalities. We have that in red, the 10-year average in blue, the 30-year average in yellow. That's from 1990 to 2019, so just shy of that 30-year average. But you can see the trend. You have heat, those deaths more than most categories. Flooding, also seeing that increase. Now, we got lucky in 2019 and didn't have any hurricane deaths as reported by the National Weather Service, but still, you see how those numbers, every single number, even a single digit, a single death, impacts tens of to hundreds to thousands of people just by association. So you feel this massive impact, not only in the lives lost and the cost that actually occurs, but also the social aspect of it. So really, we need to be paying more attention to how the weather's being impacted by the climate change. Now, this is all well and good to talk about all the things that could be going wrong, but it doesn't do any good unless you figure out what you can do to help. You can talk about a problem all you want, but you need to have solutions as well. Well, this is what we're talking about. This is what we need to do. We need to educate people. You'll hear it talked about a lot when discussing climate change, but just like what I started this presentation with, not a lot of people understand the true meaning of climate change, how there's natural climate change, human-driven climate change, sometimes weather's confused. I hear it every summer and winter. We have a polar vortex like this. People say, well, where's the climate change? You have a heat wave in the summer. Hey, this is climate change. Both of those are not correct because that's 1 year of information. You need to have it compared to an average, a 30-year average. Take a look. If it's trending up and you're seeing a higher frequency of those heat impacted areas and heat waves in the summer, then by all means, you can use that in climate change conversation. But simply just saying, oh, hey, today was 45 degrees and it's the middle of January isn't enough to say that climate change is real, or saying it's 50 degrees in the middle of July. It's not enough to disprove climate change either. You also have to remove false information. Social media is going to become a plague for science because anyone can post anything they say and present it as fact. So really need to be careful and watch out for that false information and make sure that people know that it's not correct and battle that with real science. Provide sources. That's the greatest defense for that. Also, remove politics from the equation. You'll find people on all sides of the aisle, all walks of life, who say climate change is real and climate change isn't real. Needs to just be a human issue. Doesn't need to be associated with politics or anything. Science is science. Doesn't matter which side you're on. You need to believe in that science. And good sources help boost that argument and help people from all walks of life understand that. Also, we need to mitigate the effect of humans on the climate. This seems like an easy answer, but it's really not. We have solar power, we have wind energy. All of that's fine, but we need to do more research on it. You have satellite data to collect this information, something I'll show you guys in just a little bit. You have green technology, that, of course, solar power, wind energy, everything like that. Research missions. Send out storm chasers. They can study the changes in those tornado frequencies, the changes in storms by actually getting footage of it, by sending up sensors. All of that can help. Also, carbon capture technology, something that's really fascinating to see if we can actually help scrub the atmosphere of that carbon. And social studies. Study how people interact with the information about the climate, how they interact with storm warnings, how they feel about the climate changing. If you want to make people understand, you need to first understand how they get information. It's a whole chain of reactions. And the more we understand that, the better chance we have of informing our public. And then we also need to prepare for the worst. This is the bottom line, if nothing changes, just prepare. Enhance your storm chasing network. Enhance your research networks. You can provide real-time information by being a storm chaser, like I was on this picture, getting a beautiful view of multiple tornadoes on the ground at once. That you can be relayed to meteorologists. They can send that picture out, and pictures have a psychological impact over a text saying, hey, there's a tornado in your area. You send that picture out to someone that says, hey, this is 5 miles away, they're going to start to act a little bit faster. You also start to increase our emergency management organizations, provide them with more supplies, provide them with more training. That way, if something bad does happen, like a catastrophic flood or a hurricane or tornadoes, we can immediately get on that and help save lives. And also help enhance architectural designs. Down in the southeastern United States, I mentioned they have prefabricated homes. We gotta work better on that. We cannot have homes that will just blow apart at 100-mile-an-hour winds. And that way we'll be prepared for worse weather, which is worsened by climate change. It all ties together. That's the whole thing. Climate, weather, human interactions, and results. So the more we know, the more we can help prepare, and the better we can be prepared for that severe weather to actually happen. Now, here's the best slide that I can give you guys, reliable sources. Look at all the websites that I'm providing here for studying the climate. .gov, .gov, .net, .gov, .edu, .gov. Those sources that are .gov are proven National Weather Service groups, NOAA, National Oceanic and Atmospheric Administration. These are real scientists with real information. It's not like you're pulling it off of Facebook or Twitter. You are actually getting this from the scientists. And if you guys want to take a screenshot of this, by all means do it. That earth.nullschool.net one, the only .net right there, well, that's a proven website because it actually pulls information from all the other websites. It's a conglomerate of everything that's there. And all of these can tell you a lot about the climate. Just the National Climate Information, climate.gov, easiest website right there. So much can be provided just by learning. Just go out and find the information for yourself, because the more you know, the more you can help educate others. And that will dramatically help this battle to help improve the climate and keep everyone safe. All right, everyone, I think that's all that I have. If you have any questions, feel free to pop them up. And if we have more time, I can go through a couple of those links if you'd like.
Okay, one of the questions is, what made you interested in meteorology?
I was in a tornado when I was little. It was middle of the night. My family was driving back from the Cascades in Jackson, Michigan. And we were driving west straight into a line of storms. And this was back in right around 1999, I want to say. And we didn't have our cell phones that sent us alerts. We just had the radio, which was turned off. All of a sudden, the wind was blowing, the lightning got so much worse. There was heavy rain and hail, and me, being the little 4-year-old that I was staring around going, I like this. And everyone else, including my parents, were like, we don't like this. And so from that moment on, I knew it was different about the weather. And it was actually a tornado that went over the highway right in front of us, if not on top of us. And when my parents found out about that, and I said I like it, they actually got me this book, which I keep at the top of my collection here, which was Tornado Alert. Yeah, so this is just my 2nd grade book, and it told me everything that I wanted to know about the basics of tornadoes. And it goes to show you the importance of reading as a little kid, because this taught me all the information that I needed just to get into the love of weather. So then I bought more books and more books and more books and more books. And I just kept reading, and I realized I love this. This is what I want to do. And I've known what I've wanted to do since I was about 5 years old. And that gave me so much more time to look into, okay, I know I want to study the weather, but do I want to be in the government? Do I want to do private sector and make money? Or do I want to be a broadcaster and be poor, but also help out people? And I went with the broadcast one because I guess my personality just works well with TV. And I love talking with people and interacting with them. And storm chasing, I could have either gone into research or broadcast, and I definitely wanted to do broadcast. So it all started when I was 4, and now I am the way I am.
We also have a question, why can't you eat icicles, Katie?
Yes, because they contain, well, they could contain bird poop, tar, they could contain asbestos, anything that's on your roof, really, that roofing material is made out of, can be broken down into small particles, the molecules of it, and that gets swept up in the water from melting snow or really just any rain. If that freezes up into an icicle, all that gets trapped in it. So you could be eating, without knowing it, bird poop or dead animals, or maybe get that little hint of a taste of a basketball that maybe landed on your roof and never came down. All that material is going to be frozen up into an icicle. Not to mention the ones that form on your fender of your car. Someone at my work ate an icicle off of their car, and I almost vomited in front of them because you have all the dirt and grime and road salt, and it just don't eat icicles. Just please don't eat icicles.
That is so funny. We also have, why is it getting colder in the winters if the globe is warming?
Absolutely. So the global climate change is dealing with extremes. And well, one of the extreme events that we can have happen is known as the polar vortex. It's that spinning bit of air that happens right above the poles, north and south poles. And when you get weaker winds, that allows that spin to slow down just enough that the cold air can kind of drip down. And it's just like pouring icing on top of a cake, and it just kind of floods all over it. That's what happens with the cold air when the wind weakens. Well, one of the ways that the wind can weaken is if you have decreased temperature gradients. If everything's starting to warm up, or say the poles are starting to warm up faster than near the equator, which is what is happening, you're going to have a weaker difference of cold air to warm air. It's going to be mild air to warm air instead of that. And that decreases wind, because temperature differences cause the wind. Cold front, warm front, that's just a fancy way of saying cold air meets warm air. That's where you're going to find wind. So if you have coldish front versus warm front, you're going to have weaker winds. And the weaker winds allow that cold air to spill down and drop into our areas that cause these abnormally cold conditions. I hope that explained it well enough.
Yeah. So another person asks, what's your TikTok?
Yes. Okay. So it's at weather_Katie, Katie. You'll know it because there's one video that has like 16 million views, and then I got shadow banned, so I only have like a couple thousand on the rest.
Oh no.
But I'm also on TikTok or Twitter too. So if anyone, yeah, there you go. Thank you, Mr. Perry. If anyone wants to follow me, I'm going to be posting my storm chasing stuff. The point of it is to make science fun. I grew up watching Bill Nye, so I figure, what the heck? It's a new generation. So I'm going to be doing a lot of storm chasing, live streaming, and stuff on there. So if you want to learn more about the weather or just have a laugh occasionally at science, then follow me.
Sounds good. Why are the poles warming faster than the equator?
Well, depends on who you ask. There's a lot in the science that's left up a little bit. How's the best way to put it? There's some different theories as to it, but for now, the best way to put it is, there's really not a best way to put it. Because when I went to school for this for 4 years at Valparaiso University, like you mentioned at the beginning of this, and we spent an entire unit talking about climate change. There's the weakening of the winds, which people say, for example, could cause warm air to intrude more. There's the difference in just global heat and how that can be more centered around the poles. If that warmer air tends to flow a little bit farther north, that changes the temperature. It's really a lot of different options at this point. And I keep an open mind to it. Some people are more set in this happens because of this happens because of that. As long as there's multiple reasons why it could be happening, I am open to all of them. Long story short, though, we do know that the poles are warming a lot faster than the equator.
Someone else wants to know, what's shadow banned?
Shadow banned is when someone reports your account. The girl who was eating the icicles in my video reported my account and says that you're doing improper things, and TikTok doesn't take the time, because they're a massive entity, to check and see if you're actually breaking the rules. So they just don't let people see your content. So like I have 170 some odd thousand followers and only 1,000 views. And that shows you that you are being banned on people's accounts without them telling you that you're being banned. Were there any other questions?
All right, so no more questions in the chat.
Alrighty.
Thank you so much for spending your time with us today. I really
Absolutely.
appreciate it.
I love it.
we're gonna have to close the meet
Alrighty.
and start the ending session.
Fantastic.
All right, see ya.
Bye, everyone.
Goodbye.